Hello guys, my name is Balkrishna Srivastav and welcome to Code with BK. So in this video, we write a Java program to print the first and Fibonacci numbers. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 1 or 2 are subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So I have to print the first and Fibonacci numbers. And what are Fibonacci numbers? Fibonacci numbers are basically a sequence that starts with 0 and 1. So the first two terms of the sequence are fixed, and to find the next term, you find the sum of the previous two terms. So the next term after 0, 1 is 1, which is the sum of the previous two terms. Then we have 2, which is sum of the previous two terms. Then 3, which is the sum of the previous two terms, 2 and 1. 5, which is the sum of the previous two terms, 2 and 3, and so on. Okay. So if you want to generalize this sequence, you can say nth Fibonacci number is the sum of the last Fibonacci number and the second last Fibonacci number. Okay. And the first and the second terms of the sequence are fixed. Okay. So for example, input n equal to 5, we need to print the first 5 Fibonacci numbers, which are these. And for input n equal to 10, we need to print the first 10 Fibonacci numbers, which are these. Okay. So I have taken two functions to find the nth Fibonacci number. The first one is basically getting me the nth Fibonacci number using recursion. And I've already posted a detailed video on how to find the nth Fibonacci number using recursion. I will add the link of the video in the description. Alright, I've taken the code from there. And then there is this method that finds the nth Fibonacci number using iteration. Again, I have explained this in detail in a separate video, the link for which I am going to add in the description. Alright, so I already have methods to get me the nth Fibonacci number. And I can use either of these to get me the nth Fibonacci number. So to get the first n Fibonacci numbers, all I got to do is iterate from 1 to n and get the ith Fibonacci number using either of these methods. Okay. So first I am going to use this recursive one. So I am going to say static void print first n Fibonacci numbers. Okay. Takes an integer n and prints the first n Fibonacci numbers. Iterate from 1 to n. Okay. And in each iteration you call this nth Fibonacci recursive. So I say okay plus a space. Alright, and I pass I here. Okay, so calling the function to give me the nth Fibonacci number, passing the ith Fibonacci number to get. Alright, I goes from 1 to n and a space after printing each number. Alright, and then I can change a line after I print all of them. Okay, alright. So for n equal to 10, let me call this function. Okay, I can add a message. Okay, first plus n plus Fibonacci numbers are. Okay, so let me run this. So I get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, which is the output I need. Okay, alright. I can write another method. Okay, I will call this 1 and call this 2. That will use nth Fibonacci iterative. Okay, and then I call the second version now. Okay, so let me run this. So second version also gives me the same output. Let me increase this value so to 20. Alright, so I get 20, first 20, I increase this value to 30. Okay, first 30 Fibonacci numbers. Alright, so I'll tell you a couple of more things here. First is which method to use, which is the faster one. And secondly, what if we have very large Fibonacci numbers? How do you handle that? Okay, so which method to use from these two? So this method is actually very slow because in this approach we are generating the same values again and again. Alright, so we can time this. We can say long start is equal to system dot nanotime, system dot nanotime. Okay, and we can say long end is equal to system dot nanotime. Okay, so I can say sys out time taken, okay, is plus end minus start plus nanosecond. Okay, and I'll keep this print outside so that start and stop time this function. So I'm going to call the first one, which is using the recursive method. So I'll say time taken recursive approach. Okay, change a line. Okay, I'm going to copy this exact thing. Okay, I already have start, I already have end. Okay, I just call 2 instead of 1. Okay, so this will be timed, which is calculating the first n Fibonacci numbers by calling the recursive approach, and this one is timing this method that prints the first n Fibonacci numbers by calling this helper method. Okay, alright, so let me run this. Okay, so the first one, that is the recursive approach, and this is the iterative approach. Okay, okay, so the first one takes 13969651, which is much larger than this one. All right, so this recursive one is comparatively very slow. All right, so right now this seems faster than this, but we can further reduce time. How? In this case, again we are calculating the same terms again and again, so I can use one single loop that runs in on time to print all the first n Fibonacci numbers. So I'll say static void print first n Fibonacci numbers 3. I will remove this line. Okay, I will copy this exact same thing. Okay, so I'll say I is iterating from 1 to n, and in this case we were returning 0 for 1, 1 for 2, and then we will calculating term for I equal to 3 onwards. So that is what we do here. If I equal to 1, I am simply going to print 0 with a space. Okay, if I equal to 2, I am going to print 1 with a space. For I equal to 3 onwards, I'll say else if, and then I'll say else. Okay, for I equal to 3 onwards, I am going to say my next term is last term plus second last term, and since I am going to calculate next term from I equal to 3 onwards, so my last term is going to be 1 and my second last term is going to be 0. Okay, and I'll have to declare them as well. Okay, and then int next term, set it to 0. Okay, I calculated my next term. For I equal to 3 onwards, I am going to print my next term. Okay, followed by a space, and update the second last term and last term. All right. Okay, finally change a line. So in the method where I was getting the nth Fibonacci number using iteration, I was actually calculating all the Fibonacci numbers before the nth Fibonacci number to get the nth Fibonacci number. Right, so I can use the same loop to print all the Fibonacci numbers from 1 to n. Okay, so I'm going to call print Fibonacci numbers 3. Okay, this method. All right, and I'm going to say the same message and change a line after it. Okay, comment these for now. Okay, running this. Okay, first 30 Fibonacci numbers are 0 1 1 2 3 5 8 30. All right, gives you the same output. All right, now if we time this, this is going to be much faster, okay, than the previous one. So I'm going to say start, I'm going to say end. Okay, and I'm going to print the time taken by optimized approach. All right, okay, running this. So the first one takes 11316987, second one takes this much, and the third one takes much lesser time. All right, and this increases when you increase n. So if n goes to 40, all right, the recursive one is very slow, then this one, and then this one. Okay, so I am going to comment out this recursive part. Okay, because this is going to get very slow with time. Okay, so now let me comment this part as well. Okay, because we know we use this method only to print the first n Fibonacci numbers, because this is the fastest. Okay, now I'm going to increment n. Okay, make it 100, and let's see the output now. Okay, so after a certain point you can see that we have a negative value, and we have a negative value here because the Fibonacci numbers being generated have gone very large and cannot be stored into an int. So you can either use a long type, okay, replace all this int by long, or you can use big integer. Okay, so I am going to show you a method with big integer. Okay, So I'll say big integer, okay, import from java.math, big integer, second last term is new, big integer, pass 0. Okay, you have to pass the integer value of which you want to create a big integer as a string. Okay, similarly I'll say my last term is 1 and my next term is 0. Okay, comment all of this. Okay, and I have to print the first n terms. So for 1 0, for 2 1, for 3 I'll say next term is last term plus second last term, so I'll use the dot add second last term. Okay, you print the next term, you update second last term, and you update the last term. Okay, so now I'm going to call the fourth function. Okay, and I'm going to say the same message. All right, so you will see now the second output is going to have all the correct values. Okay, so till here it is all good, all good, all good, all good. All right, till here everything is okay, but here int loses its range. Okay, but big integer is carrying on correctly. Okay, the value keeps increasing and big integer is fine. All right, so let me finally time this. So I'm going to say start, I'm going to say end. Okay, I'm just print before the starting. Okay, and okay, and printing the time taken is using big integer approach. All right, okay, and commenting this. Okay, so you see it is not a lot of time, pretty fast and pretty effective as well. All right, so this was the solution to print the first n Fibonacci numbers, and we saw when we took the brute force approaches initially. All right, where we call a function that finds us the nth Fibonacci number. Okay, and we call this function n times based upon the value, and then we optimized it to use a single loop. Okay, and then we further saw if we want very large values that cannot be stored into an int or a long type, we use big integer. Okay, so this was the solution to this problem, and I hope this was helpful. So if you like this video, if you find this helpful, please do subscribe to my channel. And if there is something that you did not like about this video, please just don't press the dislike button. Please also let me know in the comments what was it that you did not like about this video, so that I can improve in my further videos. And you can also let me know in the comments if there is a question you want to solve or if there is a concept you want to discuss. Thank you.